Okay, so in this video we're going to look at solving quadratic equations and look at a couple of examples and word problems. So just to start off with something simple, x squared equals 81. If we're solving something like that and there's no x term, we can simply just square root both sides. So we get that x can equal 9. Now, usually the number of exponents to the overall degree will let you know how many solutions you can expect. So we know that by checking back, positive 9 isn't the only thing that squared would give us 81. Negative 9 works as well. So if you ever have the case where you are square rooting, don't forget to look at positive or negative. Because yes, positive 9 works, but negative 9 times negative 9 would equal 81. Well, what about something like this? X squared minus 5x equals 6. We could do a little bit of guess and check and try and test values. So maybe we try 1. So 1 squared minus 5 times 1, well that's 1 minus 5, that's not 6. What if we try negative 1 squared? So that gives us 1 plus 5. And that one equals 6. But what if our answers to this aren't just whole numbers, right? What if this equation had fraction or decimal answers? Or how do we even know that this is the only one? Like this one tells us that yes, x is equal negative 1, but what else? And is there a more efficient way that we can do this? Because usually if we were solving a linear equation, we would have x on its own and bring our constant over, but that doesn't work out so well when we've got an x or an x squared term. If we were to try even factoring, let's say x and then x minus 5 to get 6, well, there are so many possibilities that could even multiply to 6, right? Or even here, there are so many possibilities that can subtract to 6. So solving our quadratic equations doesn't work out very nicely this way. Sure, it's possible most of the time, but it's not very efficient. So rule of thumb, try solving by factoring if you can. If not, we can try something else. So let's try this example, just solving by factoring. So first thing you need to know for this is set your equation equals 0. So if we were working with this example up here, we'd need to bring the 6 to the other side so that we'd have x squared minus 5x minus 6 equals 0. Okay, so make sure you've got 0 on one side of your equation. Now, it's up to you to decide what type of factoring it is. Do you have difference of squares? Is it product sum, tricky try? Can you take out a common factor first? So let's just go through and see what we can do with this one. So unfortunately, because of the 7 and the 5, we can't take out a common factor. But let's see if we can try our tricky trinomials. So 2 and negative 15, we're looking for stuff that'll multiply to negative 30. But we're looking for two numbers that also will add to negative 7. Well, going through my multiples of 30, I can do 1 and 30, 2 and 15, 3 and 10, 4 and 4 doesn't work. We could do 5 and 6. So for us to add to negative 7, I think we've got 3 and negative 10. So I'm just going to factor this one by decomposition. So let's break apart the 7x into negative 10x plus 3x minus 15. So we're splitting up that middle term there. From here we can look and see what's common between these two terms. So we can take out a 2x, we're left with x minus 5. And if we take out a 3 from here, we're left with that same x minus 5. So our overall factored form of this is 2x plus 3 and then x minus 5. So factoring is only one part of this. Factoring does make it easier, but we're not done once we've factored. So remember, we're trying to figure out what x can be so that these two things will multiply to 0. So we have two options. Either this first bracket is 0, because 0 times anything is 0, or the second bracket is 0, because whatever this is times 0 is still 0. So let's look at this first bracket. 2x plus 3 equals 0. If I bring my 3 over, I get that 2x equals -3. And dividing by 2 gives me x equals -3 over 2. So that's one option, and if we were to sub it in and check, we could get that. Let's work with our other one. If x minus 5 is 0, then x equals 5. So usually, like I said, solving by factoring will be the easiest way of approaching these types of problems, but it's not the only solution, and not all your equations are going to be factorable anyways. So that's just one nice example. All right, let's go over this beautiful quadratic formula. So we need our equation to be in standard form. And what that means is we've got our equation isolated for y, or isolated for f of x. We've got our x squared term first, then we've got our x term, and then we've got our constant. And a, b, and c here are all just going to be coefficients. These guys are all just constants, or real numbers. Okay. So our quadratic formula, the way we solve for that is that x can be either -b, then we've got the plus or minus square root of b squared minus 4ac all over 2a. If you are using all of this in one step, I find it helpful to use brackets around the top. If you'd like to show it in more steps, go ahead and just leave it as is. And again, we know that when you're taking the square root, you can have the positive or negative. So we're not actually putting x's in the equation, it's just the coefficients there. Now hopefully another term that you've heard already is the discriminant. That's just the part that's inside the root. So our discriminant is the b squared minus 4ac. And this guy's helpful because he tells us how many solutions there are going to be. So first up, we know we can have up to 2 solutions. And that happens if we have a positive number in the root, if we have something that we can actually square root. So 2 solutions if d is greater than 0. So we get 2 solutions if this number is positive. We get 1 solution, 1 value of x, if d is just 0. Because think about it, if this is 0, then you've got -b plus 0, -b minus 0, and those two are the same. And then our last option is 0 solutions. And this happens if the discriminant is negative, if the discriminant is less than 0. And the reason that is because we can't actually take the square root of a negative number. It's not real, it's not defined. So if you're even, sometimes you might even want to check, is this going to have answers? You could find your discriminant first, take a look at the value of it or the sign of it, and then you might be saving yourself some work there. Alright, so let's try an example of just how to use the quadratic formula when it might be a good case to use. Let's say we were trying to factor this one. We'd be looking for something that multiplies to 30, adds to -4. Don't really feel like doing that. Maybe you just don't want to do it, or maybe, it might not be factorable anyways. For all of these questions, let's make sure we determine how many solutions. So this means use the discriminant, and then we're solving for x. So our -5, that's a, -4 is b, -6 is c. So first up, our discriminant, b squared minus 4ac. We want all of b squared, so we want -4 all squared minus 4 times -5 times -6. And it looks pretty clear to me that this one's not going to work out, so -4 squared gives us +16. These 3 negatives means whatever this value is, we're going to end up subtracting anyway. But it's going to be 4 times 5, which is 20, times 6 minus 120. So 16 minus 120, we're getting -104. So because discriminant is less than 0, discriminant is negative. there are no solutions. So there's nothing to solve for anyways. We're going to get negative 104 inside our square root. So what's the point? We know we're going to get error here, so we're going to get no solutions. All right. Not too bad so far. Let's try this next one. And again, our discriminant is b squared minus 4ac. And our quadratic formula is right there as well. Okay, so this guy, a, b, and c. Let's first start off by solving for our discriminant. Negative 12 squared minus 4 times 4 times 9. So 144, and then 4 times 4, 16, times 9, hey, 144. So here we get a discriminant of 0, and because we're going to be square rooting 0, we get one solution. So this one we don't really need the plus or minus because our two answers are going to be the same. We're either adding 0 or subtracting 0. But I am going to show subbing it all in just to be safe. So so for here we want to make sure we're putting negative b. If b is negative already, just give yourself brackets. Or if you want, you can simplify, just break it down already. I am going to show just the step here of subbing things in. So that's a negative 12 squared minus 4 times 9. We already know this is 0, but just for the sake of it. These negatives cancel, so positive 12 plus minus root of 0 all over 8. So 12 plus 0 or 12 minus 0 still gives us 12. And if we want to bring this down, if we want to divide it out, it's really up to you, but this will simplify to 3 over 2. So this is the case where you get one solution only. You're going to have 0 in the root, and you can see in the discriminant, based off of getting a value of 0, that you're only going to have one solution. Alright, let's see if C is any different. So first up, A, B, C. Our discriminant is b squared, so negative 6 squared minus 4 times 5 times 1. 36 minus 20, so our discriminant here gives us 16. Now since that is greater than 0, since it's positive, we're going to have two solutions. Okay, so let's actually try and go through and solve this. So x equals negative b. So another case where we've got to do the negative 6. If it's a question like this where you're finding the number of solutions first and then solving, I would be okay if you went right to 16. So let's do that in our case here. And then 2 times a, 2 times 5. So our x can be 6 plus or minus. We're going to do a root of 16 now, so 4, and then over 10. So once you get to this form, you want to make sure you're doing whatever is in the root first, then you're taking the square root of it. And then once we get up to here, we have two options. One of our answers is 6 plus 4 over 10. So let's call that x1. So 6 plus 4 is giving us 10 over 10, so 1. And then our second option is if we use minus, 6 minus 4 over 10. So 2 over 10, or if we simplify, 1 over 5. If you want to end these off with a therefore statement as well, I should have done that up here. So here we can say x equals 1 or x equals 1 over 5. It's always nice to kind of wrap things up with a therefore and have a nice kind of clear end to your statement. Okay, so that's just a little bit of the quadratic formula to show you. Those are your pretty standard examples, right? Solve this for x, how many solutions, nothing too crazy to interpret there. Let's do a couple of different types of problems. So one when we're thinking about the graph, and then we'll do one with an application. So first up, a parabola is given by f of x equals 2x squared plus 5x minus 8. So the first part of this is asking us, when does the parabola have an x value of 3? And then the second is asking us, when does the parabola have a y value of 17? So really what they're asking us is to solve for the other variable. So this guy wants us to find y, this is find x. X is. So let's start with A. If we know our x value is 3, that's pretty simple. We can do f of 3, sub in 3 for all your x's. And don't forget, you have to start with exponents here first. You can't do 6 squared. We always have to start with BEDMAS. So this is going to be 2 times 9 plus 15 minus 8. So 18 plus 15 minus 8. And it looks like we're going to have 25 there. Great. So we can say y equals 25 when x is 3. Easy enough. Now for part B, we're doing the opposite. When does it have a y value of 17? So we know our y is 17. So we're going to replace our entire f of x with 17. Okay. So this one we needed to sub in something first before we went to try and solve for x. Now don't forget, for any of these equations, we need to move it over so that it equals 0. So moving this 17 over is our first order of business. Just checking, doesn't hurt. Okay, so if this were me solving here, I would always try and factor. So this 2, maybe I see if there's a common factor. No. Maybe I see now if I can do tricky trinomials. So something that'll multiply to negative 50, but add to positive 5. Maybe it'll work, maybe it won't. In this case, doesn't seem like it. The only things that'll multiply to 50 are 1 and 50, 2 and 25, 3 is not going to work, 4 is not going to work, 5 and 10, 5 and 10, huh, alright, let's do it this way. So, it looks like 10 and negative 5 are our winners here. 10 times negative 5 will give us the negative 50, and then 10 subtract 5 works. Okay, so I didn't think this one was factorable. So 2x squared plus 10x minus 5x minus 25. Now if you thought, okay, maybe, screw it, I don't feel like factoring right now, I'm not doing it, I'm just going to go straight to quadratic formula, go for it. Like, who am I to tell you what to do? So for here, we can take out 2. Here, let's take out negative 5. We get some common factors, which is always good. And then once we're at this point again, we need to see, okay, what will make this entire equation 0? So my first bracket is 0. I'm way short on space here. So either 2x minus 5 is 0, which means 2x is positive 5. And then if we divide by 2, we get x equals 5 over 2. Okay, so that's one option. Looking at our second bracket, for this to be 0, x would have to be negative 5. Sometimes you can do these by inspection, and if you can, that's awesome. Other times you may need to solve for both factors, and I'm okay with both of them. If you wanted to do quadratic formula to solve the rest of this, I'm okay with that as well. The only thing I'm going to be really picky on is that you have to move this over. You always, 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 always need a 0 here. Quadratic formula factoring won't work unless this guy's at 0. Alright, one of these wonderful word problems. So the height of a ball, height of a rocket, whatever is being thrown into the air or launched into the air. This is a pretty typical quadratic formula question. So we've got this height of a ball given by a certain function. So x is our time in seconds since the ball has been launched. And then f of x will be our height in meters. We're assuming the height above the ground. So if we wanted to, we could find a bunch of stuff. Looking just by inspection, if x were 0, our y-intercept is going to be 3.1. So we know it's starting at a y value of 1.